Hey trick class, let's look at this application question for sine cosine graphs. So what we have here is a function that gives the monthly temperature for a city. 1 is January, 2 is February, etc. all the way to 12 is December. And we want to know what's the highest average monthly temperature, what's the lowest, and what's the time between the highest and the lowest. So if you're looking at this and you're looking at the questions, hopefully what you can see is A and B are asking you for T, the output. But question C is asking you for X, the input. What's the highest average monthly temperature? So the average monthly temperature is your midline right here. So the vertical shift is your average monthly temperature. And then if you recall, we go up and down off the midline with a sine wave. And the amplitude, which comes from this number in front of sine, is the maximum departure from that midline. So we rise above it this amount and we fall below it this amount. So the highest average monthly temperature would be the midline plus the amplitude. So that's that 52.85 plus the 22.75. That's my maximum. All right, my minimum is going to be the midline minus 22.75. So those are my answers for A and B. Now there's a lot of different ways you can do this next question, but the easiest thing to understand here is the time between the highest and the lowest. Well, that's a half of a period, right? From the highest to the highest is a period. That's if you're thinking like the cosine function, it starts at its max, 2 pi radians later, it's back at its max. So the highest to highest is a full period, and halfway in between on the cosine function, you're at the lowest. So that's half of a period. Well, we use this pi over 3 to come up with what a period is. So remember, it's 2 pi. All right, that's the typical period, but we're going to divide by the number that's in front of x, which is a fraction, pi over 3. So I'm putting in a parentheses because it's a fraction. So that is a full period. So a full period is going to be 6 months. That would get us from peak to peak, but a half of that is going to be 3 months from peak to the high point to low point. So that's going to be 3 months. All right, so that's how we can do this without even touching a graph, right? Not looking at a graph. All right, but let's look at the graph. So instead of t of x equals, I'm just using y1 in my calculator, 22.75. All right, so there's how I would write that with all those fractions in there. You just basically typing it left to right and let order of operations take over for the most part. All right, now once we got that in there, again, the answers to questions A and B, the 75.56 and the 30.1, that's our y min and max when we go to our window. So our y min is 30.1, our y max is 75.6. Our y scale, it doesn't really matter, but let's make it like be 10 degrees at a time. All right, our x min and max, you just think through this one. 1 is January, 12 is December, so we can do 1 for our minimum, 12 for our maximum, and we can do 1 month at a time if we want. All right, let's graph it and see what we get. All right, now, the only thing that's kind of bizarre about this at all is that this city has, January, February, March, April, like it's rising and falling again. So it's January, March, June, September, December. It's like the temperatures fall in the summer months, which is kind of weird. But it's just a model, or it's just a modeling question just to make sure that you can do the math. But you can see the highest here. You can see the lowest there. One way that the calculator can find the highest and the lowest without you having to just do what I did and know it is after you graph it, there's a button up here, calculate, C-A-L-C, calculate. You can hit second, C-A-L-C, calculate, and there's maximum. So I could go down to maximum. All right, it wants me to come up to the left and right bound of a maximum point. So all that means to do is kind of be to the left of it. So like right there's our peak roughly. Just be a little bit to the left of it. Just hit to the left a couple times. Hit enter. I go up to the right now. It says right bound. Go to the right of the peak. Hit enter. And then it says where do you think the peak is? And you just kind of hover around there and there's my peak. It'll work on it and then you can see the little cursor flashing. there's 75.6, which we got as our max, and it took place at 4. And so you can probably guess what I'm going to do next. I'm going to go to second calc. I'm going to go to the minimum, and it does the same thing. Where's the left of the minimum? Where's the right of the minimum? So there's the minimum roughly around there. I'm going to go a little bit to the left of it. I'm going to go a little bit to the right of it. Again, there's the minimum. Go a little bit to the right. And then guess, where do you think the minimum is? I think it's around there. So there's the minimum. It's at 7. So this was at 4. This was at 7. 7 minus 4 is 3. So there's a way we could do that with our calculator, doing it just 100% based on the graph. And then the other part of the video is doing it without graphing it at all.